Hello, good evening, guys. Welcome to 90 plus double power model tuition, world's first learning assurance model. My name is Mushrifa and I'm your physics teacher. And today we are here with a workout session of the chapter refraction, like light refraction. And today's day 4 workout. And as you know, like by the end of the session, there will be a return test. I hope you remember that. So, hi, Angel and Anmol. Welcome to the session. How are you guys?
Fine, ma'am. How are you?
I'm good. Okay, all right, very good, Angel. Like I was about to ask you to turn on your video. Okay, all right. That's great. All right. So, as you know, like in double power model, like we do have the session where we confirm that like you have learned like for the workout session. So today there will be a workout session, and before that, I'm gonna give you a quick revision of the concept that we learned last class. Okay, all right. So I hope everything is good and well. Hmm. Okay. All right. So give me a moment. I'll share my screen and we can start discussing, like we can start the revision. Okay. All right. Nurul, please do turn on your video. Like you said something is wrong with your thing, like the mic and all. Is it resolved, Nurul? After the update or something you mentioned yesterday, right? No. So try to resolve it as soon as possible. Okay. Hi, Shraddha. Welcome to the session.
Hello, ma'am.
All right, Nurul. All right, guys. So, some of you are yet to join the session, but still, that's fine. Like, we're gonna conduct the revision. After the revision, like, we can conduct our workout session, and after that, like, the last half an hour will be the return test. So, I hope you guys are ready with your book, pen, and water bottle handy. Did you keep the water bottle handy? Let me take a sip of water, please. All right. So, here we go. So yesterday we learned about the new Cartesian sign conventions. We learned about new Cartesian sign conventions. So which were there? There were 3 points to remember. Distances are measured considering the optic center of the lens as the origin. And right of the optic center are positive and the left of the optic center are negative. And the distance measured upward the x-axis are positive and those measured downward the x-axis are negative, and the incident ray is considered as traveling from left to the right, and the focal length of a convex lens is a positive and that of a concave lens is negative. So these were the points to remember in the sign convention. Hi Zayan, welcome to the session, and Shivashini, welcome to the session, and Danishri, welcome to the session. Okay. All right. So after that, we discuss this thing, like the same thing, like we discuss again. That is, toward the right of the optic center, it is positive. Toward the left of the optic center, it is negative. Like the something measured upward, the optic, like the principal axis are positive, and the those measured downward are negative. Okay. Okay. All right. All right, guys. Once again, let me inform, like most of you have joined the session. All right. All right, so that's about it. And after that, what did we discuss about this particular figure for this particular thing? Zayan, what is the object distance here with a new Cartesian sign convention? The object distance.
Distance
Mm-hmm.
negative 25 centimeter.
Oh, can you please say it a bit louder, Zayan?
25 centimeter.
Like with sign convention?
Negative 25.
Negative 25 centimeter. Very good. Then Shivashini, what is the image distance here?
Yes, ma'am. 100 centimeter.
Right answer. Very good. Then Anushri, what is the height of the image here?
1 centimeter.
Height of the image.
Oh, minus 4 centimeters.
That's excellent. Very good. Then, Milind, what is the height of the object?
So height of the object plus 1 centimeter.
Right answer. Very good. That's about the sign convention. Those measured right toward the right of the optic center are positive, and those measured toward the left are negative, and measured upward are positive, and downward are negative. And another thing, I'm gonna ask it to Shraddha. What is a sign like of the focal length of a concave lens?
Focal length negative.
Right answer. Then Anmol, what about the focal length of a convex lens? Is it positive or negative?
Positive.
Right answer. Very good. Okay. All right. So, how many principal foci does a convex lens have, Angel?
2.
Very good. It do have two principal foci. So, like the light that is falling on the left face, it would be like getting refracted on the right. Like it, after refraction, it would be converging on the right, and those things that get refracted or incident on the right face, it would be converging on the left. Okay. Okay, Valentina, you need to inform class teacher. Okay. So you need to inform class teacher, Valentina. Okay. All right. After that, we discussed about the focal length. Like after that, like here it was the focal length of a convex lens is positive and that of a concave lens is negative. After that, we discussed this particular thing. What is this? The lens equation. So Ira, can you please tell me what is lens equation? Like the equation.
1 by f is equal to 1 by v minus 1 by u.
Very good. That's right. So that is our length equation 1 by f is equal to 1 by v minus 1 by u. And using this relation, this equation with all the new Cartesian sign convention, we can find the answer like if we are giving the appropriate sign for each value. So we did this particular question, focal length of a concave lens is 20 centimeter. If the object is placed at a distance of 50 centimeter in front of this concave lens, where is the image form? Like we are not gonna do this particular question, like we already did it yesterday, but still like I'm going to show you like about the sign convention. So here the focal length of a concave lens, since it is a concave lens, f is equal to negative 20 centimeter. F is equal to negative 20 centimeter, and the object is placed at a distance of u is equal to negative 50. So remember guys, the light ray we are going to consider it to be falling from left to the right. So if you are measuring the object distance according to the new Cartesian sign convention, we are going to get it to be negative always if it is on the left of the lens. Okay, if it is located on the left side of the lens, so the object distance, and if it is not mentioned whether it is left or right, you have to take it to be on the left. The object, you have to consider it to be kept on the left side of the lens. So the object distance is going to be always negative irrespective of the lens, whether it's a convex or a concave, it's going to be negative. And the focal length is negative for a concave lens, and the image distance will also be negative for a concave lens. Because so Valentina, what is the nature of the image formed by a concave lens? What is the nature of the image formed by a concave lens, Valentina? Mhm. I'm not able to hear anything. I'm not able to hear anything, Valentina. No. Maybe like your network is not letting you speak. Okay. All right. Then Shivashini, what is the nature of image formed by a concave lens?
Is it virtual and erect?
It is a virtual and erect. So that's true. The nature is virtual and erect. So since it is a virtual, it's gonna be formed on the same side as that of the object. That's why the image distance will also be negative for a concave lens, which means f will be negative, u will be negative, and v will be negative. FUV is gonna be negative for a concave lens. Excuse me. All right, Shraddha, that was answer that we found yesterday. That's why I did not ask you guys to find it again, but still you found that's really good. Okay. All right. So here we go with the next thing. It was magnification. So is Angel.
No, ma'am, it accent came.
But it's fine. You can say about the magnification. What is magnification?
Magnification is the ratio between the height of the image by height of the object.
Height of the image by height of the object. That's right. Magnification is a ratio of height of image to the height of the object. So what if we are gonna specify the magnification in terms of V and U, Ira? Once again, guys.
Um,
Yes, Ira, please go ahead with your answer. Meanwhile, I'm gonna plug in my charger. So I'll be listening to you. Please say the answer.
M is equal to V by U.
That's absolutely right. Very good. So magnification is the ratio of height of the image to the height of the object, and it shows how many times the image is larger than the object. So magnification M is equal to height of the image by height of the object, HI by HO, or M is equal to V by U. So Anushri, what is the sign of the magnification indicate? You can say about one of the sign.
If the sign is negative,
Mhm.
then the image, the lens would be real, and the nature would be real and erect. And if it the value
Repeat your answer, Anushri. I'm gonna give you one more chance. Something was wrong. Only one word was wrong in your answer. So, yeah.
if the sign is negative, then the nature of the lens would be real and inverted. And the size, if it's the value is greater than one, then it'll be enlarged. And if it's less than one, it'll be diminished. And if it's one, then it'll be same size.
Okay, now you corrected it. But of the image, okay, not of the lens. Nature of the image, it's gonna reveal. Okay. All right. The rest of the thing you corrected yourself. Very good. Okay. All right. So, Milind, what is the thing about if the magnification is positive? What does it indicate?
Magnification is positive, then the image will be real and no virtual and direct.
It would be virtual and erect. That's the thing about the sign of the magnification. Positive and negative sign of number indicate the nature of the image. If M is a negative, image is real and inverted. And if M is positive, it is virtual and erect. So if the magnitude of the magnification is greater than 1, it is enlarged. If the magnitude of the magnification is less than 1, it is diminished. And if it is equal to 1, it will be of same size as that of the object. So this particular question, Shivashini, can you please let me know the value with the sign? Not, I do not want you to calculate the thing again. It's okay if you do not calculate it again, but still let me know the sign convention here.
Ma'am, here focal length will be negative 15,
Okay.
and then
Centimeter, then
yeah, and then image distance will also be negative.
negative,
Yeah, 10.
negative 10
Yeah, and then
centimeter. You have
meter.
to mention the
Okay.
unit along with it. Okay. All
Okay.
right then.
Yeah, and then the object distance would be also negative. Should I do it,
Why?
ma'am?
No, that is not necessary. Yesterday we already did this thing, so that is not necessary. So here, can you please predict, Shivashini, what will be the sign of magnification?
Magnification would be negative.
No.
Oh, it's
If it is
positive.
not negative, then it's be positive. That's obvious. So how it got it to be positive? How it
Uh,
became positive?
V by U.
Exactly, like V and U are negative and negative. That's why it turned out to be positive. Okay. All right. Then Zayan, please mention the sign convention here.
U will be negative.
Okay. Like, please mention the value also, exact value. U is equal to how much?
Negative 30 centimeter.
Negative 30 centimeter. Okay. Then,
And V will be 60.
is it a positive or negative?
Positive
60 centimeter plus Y. Why is it positive?
because it's forming on the right side of the lens.
Like, how could you say that it is formed on the right side of the lens? Based on what?
Because it's a lens.
No, a lens can also form, like a concave lens do form the image on the left side, like the virtual image on the left side. And the convex lens also form a virtual image on the left side, like when we are using it as a magnifier.
Because it's a real image.
Hmm.
Because it's a real image.
So real image means?
Positive.
Okay, so which lens it would be?
Convex.
Exactly. It would be a convex lens and V is equal to positive. That's absolutely right. Okay, all right. Then next question is for you, Milind. Please let me know what all the variables are given here and like the values are given here and with the sign, appropriate sign.
Object height will be positive.
Object height will be positive. So let me know what is the value HO is equal to
Positive 5
positive 5. What is the unit?
centimeter.
Yeah. So the unity is very important, guys. Each of you, like none of you should forget about it. Okay. Then another thing, any other thing mentioned here?
Focal length will be positive 20
Exactly. 20. What is the thing after that? 20?
centimeter.
20
20 centimeter.
centimeter. Then
Uh, Distance of object from it. You will be negative 30 centimeter.
you will be negative 30 centimeter. Very good. So we need to find here the position and the nature of the image using like F and U. We can find V like the lens formula. And after that, we can find the magnification and we'll get the nature of the image. Okay. All right. Another question is here. I want Ira to explain like the values over here.
The height should be positive 4 centimeter.
Positive per centimeter.
4 centimeter.
Then,
And U should be negative 30 centimeter.
then,
And the focal length should be negative 20 centimeter, positive 20 centimeter.
is it positive or negative?
Positive.
Exactly positive. Okay, you should not get confused because convex lens will have a positive focal length and the concave will be having negative focal length. Okay, then is there any other data given here? Okay, all right, that's right. Then next question. Okay, so I want Shraddha to explain this. Like I did not give you any chance, right, Shraddha? No, right? Yeah.
The U will be minus 10 centimeters.
Okay, so U is gonna be negative 10 centimeter, then
And F will be positive 20 centimeters.
plus 20 centimeter.
Yes, ma'am.
Okay, so we need to find the position and the nature of the image. So, like, another thing is here. So, Angel, complete the following ray diagram. Can you please tell me, like, depending on this particular object position, where will it form image?
Behind the mirror.
It is not a mirror at all. It is
Sorry,
lens, Angel.
behind the lens. Sorry,
Behind the lens means on right side, you're saying.
on the left, l- like between 2F and F1, 2F1 and F1.
Like between two F1 and F1, you're saying like the image will be formed.
Yes.
That's absolutely wrong, Angel.
Oh,
So just look at the object position. I'm gonna give you one more chance to rectify your mistake. Object position.
it's between F and optic center. So
The object is, yeah, in between F and optic center. So So,
Um,
like we learned, right? Different position at infinity, at 2f, like beyond 2f, at 2f, between f and 2f, then between f and o. 6 cases we learned.
yeah, the light ray will pass through focus and optic center, and then will form like a in between of 2F and F1. That's what I remember.
Okay, all right. It might form somewhere in between. So the exact position is not clear. So, all right, Angel. So let's check with the final answer. Like here, it is formed beyond 2f on the same side. That's why in this particular case, better not to mention any particular position in between or at or anything. Just mention it will be on the same side as that of the object. So, what is the nature of the image, Angel?
Um, Virtual and erect.
Exactly, this is virtual and erect. So this is the case where we use a lens as a magnifier. We are gonna keep the object like very close to it, like in between F and O. So do you remember yesterday's question? Like in the daily test, there was a question, right? Like which lens, which convex lens we have to use so that we can use it as a like what was it? For a reading, like for a magnifier. Do you remember that question? And the options were like a convex lens of focal length 50 centimeter was there, and a convex lens of focal length 5 centimeter was there. Okay. So for reading, we usually take a small focal length one. So that we'll be getting it to be like magnified, it would be, and we will be keeping it very close to it, like within the focus. Okay, very close to it, will be moving and it will be forming a virtual image, all right? Then Shraddha, I already gave you the chance. Someone was there in between you and Angel. So I think it was Anushri. No, Anmol was there. Yes, Anmol. Like a few minutes back, you were in between, like your position was in between uh, Angel and Shraddha. So I noted that like the second one, like the Angel is in the first position, then you were there, then it was Shraddha. So I was like about to call like the second one I have to call. Then when I was calling, it was Shraddha there. So Anmol, can you please describe about this particular thing?
Yeah, find the nature, position, and size of the image formed. So the image will be virtual, virtual and erect. Uh, the size of the image will be
About the
enlarged.
FU and or like the data given, can you please explain about it?
About that,
The
yeah,
sign. Mhm.
focal length. Focal length will be 20, plus 20 centimeter, and image object height will be that's not given. Image object distance will be minus 18 centimeter.
Mhm.
Yeah,
That's all given
that's
here. Yeah,
yeah.
very good, Anmol. Okay. All right. As you can see, guys, here it formed a virtual, erect, and magnified image. And yesterday we found that it was 10 times magnified. The image was 10 times magnified. Okay. So after that, we learned about power of a lens. So Anushri, can you please tell me, like, define what is the power of a lens?
It is the degree of convergence or divergence of rays of light coming from the left side.
Okay. All right. Like, better not to, like, term it to be from which side. It is not necessary. Okay. Like we are, according to our new Cartesian sign convention, only we are taking it to be from left. But the power does not mean that like always it have to come from left. So don't include that like from left side. Okay. So the degree of convergence or divergence of the light ray achieved by a lens is known as its power of the lens. And it is a reciprocal of the focal length expressed in meter. So Milian, what is the equation to find power in terms of focal length? Milind, what is the equation of power, Milind? Ah, am I audible to you guys?
Yes, ma'am.
Yes, Milind, what is the equation to find power? P is equal to
Work by
Oh my God, I'm asking about the lens, not the power, like the energy, like not that particular power, not the power in what. I'm asking another power that of a lens. So, like I was
uh,
wrong. Actually, I should have asked what is the power of a lens, like the equation
uh,
to find power of a lens. Yeah,
1 by F.
exactly. P is equal to 1 by F. And what is the SI unit, Milind? SI unit of power of lens. Mhm.
Yes, ma'am.
What is the SI unit of power of a lens?
I don't know.
You should know. Like yesterday, we did that. We did many questions with like finding the power, using the power. We found the focal length. Right answer, Industry. So, Ira, what is the SI unit of power?
The
Exactly, that's diopter. So the SI unit of power is diopter and it is represented by D. Do you remember now, Milind? Mm-hmm.
Yes.
All right. So, Angel, what is the power of a convex lens?
Power of a convex lens.
Mm-hmm. Is it positive or negative?
It's positive.
Right answer. Then, Shraddha, what is the power of a concave lens?
Mom, negative.
Right answer. Very good. Then, if we are going to keep a number of lenses together where the refracting surfaces are touching each other or in contact with each other, so Shivshini, what would be the combination, like the power of the combination of lenses?
Is it P1 plus P2 plus P3 like that?
Exactly, exactly. That's absolutely right. It is the algebraic sum of individual power. P is equal to P1 plus P2 plus P3 and so on. And we discuss about the uses of lens. So lenses are used where and more. What do we use lenses?
Lenses are, yeah, in specs,
Mm-hmm.
magnifying glass.
Yeah. Any other thing, Anushri, another other than specs and magnifying glasses?
Telescope.
Exactly. Then I'm gonna ask Zayan, is there any other example?
For lenses, right?
Mm-hmm. What do we use like the application of lens other than the one mentioned here?
Mm. I don't know anymore.
I don't know anymore. Okay, let me tell you, camera is also there. Like in a camera also, we do use lenses. In telescope, in cameras and all, we do use lenses. Like in telescope, spectacle camera, and in microscope. Okay, all right. So Nurul and Valentina, like your mic are not working. That's why I did not ask anything. Okay, like you won't be able to say that thing. That's why I were not asking anything. But don't feel offended. Okay, all right. So you guys can give the answer in the chat. Okay, yeah. As Valentina and Nurul, please do use chat box to give the answer. So what is the power of the like power of a lens of focal length 25 centimeter? Nurul, please give the answer in the chat. Zayan, you did not mention the unit, but the value is right, but you did not mention unit. Right answer, Shivashini and Nashri. Now it's right. Absolutely right, Zayan. So Nurul, what is the answer, Nurul? Right answer, Valentina, Shraddha. That is 4 diopter. Then the focal length of lens is 2 diopter. What kind of lens is this? Is it diverging or converging? How to find whether a lens is diverging or converging? Okay. All right. So I got few answers in the chat. Right answer. It is a converging lens because power is positive because that is a convex lens. Okay, all right. We already discussed these questions. So that's it about the revision. So now I'm gonna share the revision, like not the revision, but the workout PPT. Okay. So now I'm gonna share the workout PPT and we can start discussing the question. Like I'm gonna ask you questions. Okay. I hope you guys might be excited to do the numerals. And let me tell you, like, as we did numeral, a lot of numeral yesterday. So in the workout also, there will be a lot of numerals. So you have to calculate it as soon as possible. Okay. So the first set of question is here. The first one, an object 5 centimeter in length is held 25 centimeter away from a converging lens of focal length 10 centimeter. Draw the ray diagram and find the position, size, and the nature of the image formed. And the next one, a concave lens of focal length 0.1 meter forms an image of an object which is diminished in size by 4 times. Find the object distance and the image distance. Then a convex lens form real and inverted image of a needle at a distance of 50 centimeter from it. Where is a needle placed in front of the convex lens if the image is equal to the size of the object? And also find the power of the lens. And the fourth one, find the power of a concave lens of focal length 2 meter. And that is the simplest question you are able to see here, like you will be doing here. Okay. So everyone, please start doing like attempting the question. You have to answer each and every question. So I'll be asking any of you to answer the question, like to explain the question in detail. Okay. So please do that. Whoever finished answering the first question, please do raise their hand. I do not have a single hand raise, so everyone is doing that. Okay. All right, Angel. Okay, all right. Like if you finished it, like you can say the answer, Angel. So what is answer for the first question?
The height of the object is at 5 centimeter. And then
Okay.
the object placed U is minus 25 centimeter,
Yeah.
and focal length focal is 10 centimeter. F is
Yeah,
T.
that's right.
And then we'll put it in the formula and we'll get 16.6 centimeter.
Absolutely right.
And then we'll find H1, which is M is equal to V by U. Then we'll get height of the image as 3.33.
Is it positive or negative?
It's positive. No, it's negative. It's negative.
Are you sure?
Uh, um, yeah, it's
That's
negative.
right. That's absolutely right. It's to be negative because the magnification is gonna be negative here. So that's right, Angel. Absolutely right. Okay, very good. Then whoever finished answering the second question, please raise the hand because it's numeral. That's why I'm just asking it. And did you draw the ray diagram, Angel, for the first question? Like they have asked you to draw the ray diagram. No? So better do that, okay? I think, yeah, I have an hand raise here. Yes, Ira. So what is second question's answer? Like, please explain
Anyway,
second question.
I raised my hand for the first question, right now. Like for the ray diagram.
Mm-hmm.
So I
What
did
happened?
the ray diagram for the first question.
Oh, that's why you raised your hand. So please show your ray diagram, Ira. Okay, the position is right. And the object position. So, like, do that again, Ira. Something is wrong there. Am I right? Something is wrong, right? Something important is wrong there. Okay. All right. Then, Zayan, did you finish second question? Please answer second question, Zayan. Please explain it.
A concave lens of focal length
Mm-hmm.
0.1 meter forms an image of an object which is diminished in size by 4 times. Find the object distance and the image distance.
Yeah.
The object distance is 30 centimeter and image distance is 7.5.
Object distance is equal to how much?
30 centimeter,
And the image distance is equal to?
7.5.
Absolutely right. So, is it positive or negative?
Positive.
Mm-hmm.
Negative, negative.
Which is negative? Is it you or we?
Both.
Both are negative. That's absolutely right. Okay. So, m is equal to how much? M is equal to how much here? Like, what is the value of m you took here?
Uh, 1 by 4.
Absolutely right, Zayan. Okay. All right. So, um, Shraddha, can you please answer third question? A convex lens form a real and inverted image of a needle at a distance of 50 centimeter from it. Where is a needle placed in front of the lens if the image is equal to the size of the object? Also find the power of the lens.
V is equal to 50 centimeters.
What is equal to 50 centimeter?
V.
V is equal to 50 centimeter. Yeah.
So U will be minus 50 centimeters.
Why it will be minus 50?
Because the image would be equal to the size of the object.
Exactly. That's why the the thing is gonna be like that. Okay, that's absolutely right.
Now I'm still finding the power.
Mm-hmm.
I'm still finding the power.
Okay, please do find the power. So, like, did you got the focal length? Or Shraddha, are you using the lens formula to find the focal length here?
Yes, ma'am.
Is that necessary? At which position we do have it to be same?
Oh,
Mm-hmm.
2F,
Exactly. So, what is F here?
25.
Yeah, absolutely right. So now tell me, like, what is the power?
1 by 0.25,
Mm-hmm.
which is 4.
Absolutely right. Very good. Okay. Right answer, Anmol. Anmol gave the answer in the chat. Okay. All right. Then fourth question. Okay, Anmol. Yeah.
Yes, ma'am. So here the focal length is given as 2 meters. Since it's a concave lens, it's minus 2 meter. Then we just put in the formula p is equal to 1 by f. So p is equal to 1 by minus 2, which is equal to 0 minus 0.5 meter diopter.
Absolutely right. Yeah, absolutely right. Minus 0.5 diopter. Like the fourth question was the simplest one, right? Among the other three. And like the second question can be a bit confusing because like they have given the size is diminished by 4 times. So that can be confusing, but still like if you read it carefully, you will understand that it is 1 by 4. M is equal to 1 by 4. Magnification is equal to. So I hope these four questions are clear to everyone. Is that clear? Hmm. Is there anyone finding anything difficult? Shivashini, is everything clear? These four. Okay. Ira, is these four questions are clear? If everything is clear, guys, I'm gonna give you the next set of questions. Nurul and Valentina, is that clear? So I'm gonna give you the next set of questions. Here it is. Which of the following lenses would you prefer to use while reading small letter found in dictionary? So like you had to, I had to give the options. Okay, I'm gonna give you the options. Okay. All right. So here is the question. Fifth question. So it is MCQ. So please, everyone, give the answer in the chat. Right answer, Angel. And it would be better if you could give the justification for your answer. So, um, Shraddha, can you please give the justification of this particular question and like the answer? You gave the right answer in the chat, so please give the justification.
Ma'am, first we take convex lens because it's a
Mhm.
converging lens. So
Okay.
the images and the focal length as 5 centimeters.
Why can't we choose a 50 centimeter focal length one?
Uh,
Why should we prefer 5?
because you should keep it above, no wait, in front of the focal length to get a magnified image.
So is it in front of the focal length or within the focal length?
Within.
within the focal length. And also, what will happen like if we are using a 50 centimeter or 5 centimeter, we are going to get a maximum power.
5 centimeter.
That's the reason. Okay, to get the maximum power, we have to use a 5 centimeter focal length. Okay. Okay, all right. So it's gonna be 20 diopter, right? If it is 5 centimeter, 100 by 5, that's gonna be 20. So if it was 100 by 50, like it would have been 2, like the power would have been 2 diopter. We want to like magnify it maximum. Okay, that's why we should use the C. Okay, all right. Then next set, like the 6, 7, 8 are there. So go through those questions. So, Valentina, please give the answer in the chat, and Nurul, please give the answer in the chat of every question. Like, not every question. Like, I'm gonna mention it to be, for the fifth, like no, sixth. Nurul, you have to give, and the seventh you have to give in the chat, Valentina. So, sixth question. Um, right. So, Milind, please explain sixth question. I'll check your answer, Valentina. So, meanwhile, Milind, please explain sixth one.
Ma'am, we use a lens formula
Mhm.
1 by f equal to 1 by v minus 1 by u. Substitute 1 by u out. 1 by u equal to 1 by f minus 1 by v, which is 1 by minus 10 plus 1 by minus 50. No, 1 by minus 10 plus 1 by 50 equal to minus 5 by minus 150, which is 1 by 30, and u equal to 30 centimeters.
So you're gonna get it to be 30 centimeter. So did you got it to be negative 30 or positive 30?
Positive,
Huh?
positive 30. Positive 30.
Do that
No,
again.
no, negative 30. Sorry, my bad.
Like which one you got actually? Was it positive or negative?
Negative.
Negative,
Negative.
then that's absolutely right. Okay, all right. So the object will be placed 30 centimeter away from the lens. And then did you do the ray diagram, Milind?
No,
No, please draw that. Then Anushri, did you draw the ray diagram for the sixth question?
No, I'm still doing it.
Okay. Then Shivashini, what about you? The ray diagram of the
Yeah,
sixth question?
I'm about to finish. It's just like this.
Once again, let me maximize the view. Only then I'll be like, can you please raise your hand, Shivashini?
Yeah, one second.
Yeah, then show it to the camera.
Here is the image.
So it's gonna be formed on that particular side. Um, okay, all right. All right, that's absolutely right. Okay. Okay, now we can lower your hand, Shivshani. And let me check your answer, Valentina, for the seventh question. Um, right answer, Valentina. That's absolutely right. Very good. Okay. Right. Right answer, Shivashini. That's the answer for the seventh question. Okay. So, Ira, can you please explain eighth question? Like you have to answer the eighth question, Ira. Can you please explain and like do?
So the image formed by a convex lens is magnified twice when it is placed at a distance of 20 centimeters from the lens. So when U is minus 20 centimeter, the magnification is
Mhm.
2
Is it plus or minus two?
minus 2
It is
minus
minus
2.
two. Yeah. Then,
So we need to find out where to place the lens so that we get an erect image that is 4 times. The magnification is 4.
hmm
So it should be placed between optic center and F.
So it should be placed between the optic center and F. So, like, how would you conclude that? Hmm? So, like, what do you have to do here? Like, how will you find that distance? Please do that and let me know, Ira. Okay. Please complete the question and let me know. Right answer and more. Um, F is right, but like you need to do that again, I guess. Okay. Let me check if I had made any mistake. Like you gave another answer and I got another answer. So let me do that again and you can do that at your end game. Okay. So, like your answer is wrong, Anmol. Okay. So, like the final position of the object that was wrong. Yeah, that's right. You gave the corrected one. That's right. Okay, very good. So, Ira, if you have finished, please let me know. You have to explain the thing like about the steps. What are different steps you need to follow here and all. Okay. Right answer, Anushri. Oh. Mm-hmm.
Ma'am, I found F, but I'm not sure what to do after that.
What happened, Ira?
I found F, but I'm not sure about what to do after that.
Okay. So you found F, you don't know what to do after that. You need to find the object distance. Like, what is the value of F you got, Ira, here?
40 by 3.
40 by?
3.
That's absolutely right. Then Anmol got the answer. So Anmol, can you please explain like what to do next after finding the focal length? So listen carefully, like you will understand. Yes, Anmol.
Yeah, so here I took it as 4 is equal to 40 by u2. So 4 by 40 is equal to u2. So we get 1 by 10. So it's minus 10
Mm-hmm.
is equal to u2.
Like in
That's how I
detail.
did.
Yeah, the thing is right.
Okay. Yeah, so m is equal to v by u, right?
Mm-hmm.
So here m we have to find
Like V, it is
m is
already given.
yeah
M is given
4
to be
times, yeah,
4. Mm-hmm.
4, yeah. So and we found out the value of v also, so which is 40. So we need to find a new value which is u2. So 4 is equal to 40 by u2, and we take 40 to the other side.
Like
So
how
4
you
by
found it to
40.
be 40? Like how you got it to be 40?
Yeah, so m is equal to v by u, right?
Mm-hmm.
So in the first is m is equal to minus 2 is equal to v by minus 20, which is minus 20 is u1 value. So then
Mm-hmm.
when we take the minus 20 to this side, you uh, can yeah, minus into minus plus, and you get 40 centimeter. This
Okay,
is the
okay.
first.
There we got it to be 40 centimeter. Like
Yeah,
V is equal to 40 centimeter there. Okay.
yeah,
So here,
yeah. So after that,
mhm,
I just cancelled and I got the value.
yeah, you just cancelled and got. But like the thing is that the fact is that here, like in the final answer also, we are gonna get it to be like a we are gonna get it to be 4 times the magnification. Like it's gonna be negative 40 actually there. Okay. But like the thing is that in this particular question, the V is gonna be the value of the V is 40. That's why you got it right and more. The final answer you got it right because of that. But what if it was another value because we changed the object distance? We have to change the object distance here. So not every time we'll be having the same distance. So like the thing you have to do is that you have to take a relation. You have to take a relation such that like from the given value of m and u, like m is equal to v by u. So from that you have to like represent like the I'm gonna write over here m is equal to v by u and m was given to be 4. So 4 is equal to v by u. So take v in terms of u. So you're gonna get v is equal to 4u. Okay. So use the length formula 1 by f is equal to 1 by v minus 1 by u. So 1 by f is equal to 1 by v means 1 by 4u minus 1 by u. Like after solving, like f we already found with the first value. Okay. Is that clear? F we already found with the first value, and Ira, you got it to be like a 40 by 3, right? So 1 by f, 3 by 4 will be equal to 1 by 4 minus 1 by u. That's going to be negative 3 by 4. So 3 by 40 is equal to negative 3 by 4u. So what will be the value of u? U will be equal to negative 10. U will be equal to negative 10. So from that, we are going to get the V as a negative 40. Like the value still is 40. That's why you got it right. And more like I hope the thing is clear, right? So you shouldn't use the V that you already found in the first case for the second case because it's gonna be like it's going to be different. Like in first case it was plus 40 and now we got it to be negative 40 on either side. The 40s are on either side. Okay. So please keep in mind whenever we change the object distance, its image distance will also change. You cannot take something that you initially calculated, but here for the focal length, like we are calculating with the first data. Why? Because it's a focal length of a lens. So like with object distance or anything, it's not gonna change. Okay. I hope that thing is clear. Like, is that clear, Ira? Okay. All right, guys. So in this particular answer, you should get the object distance to be negative 10 centimeter. You have to get u as negative 10. Okay. Yes, Ira. Right answer. So here is another question. A doctor has prescribed a corrective lens of power plus 1.5 diopter. Find the focal length of the lens and is it prescribed lens, like is a prescribed lens diverging or converging? You have to find. And the 10th question we already discussed. So if you do not want to write the answer, that is fine. But if you know the answer, then it is fine. Then the 11th and 12th you have to find. So do it as a because you do have a written test after this. So if you could do these things like ASAP, I'll give you the test ASAP. And one thing I forgot to do actually, like in the beginning of the session, to appreciate the students who scored 10 out of 10 yesterday. So Brian, Zayan, and Anmol, Sahasra, Angel, Valentina, Anushri, Shraddha, and Ira and Nurul scored 10 out of 10 yesterday. So excellent, guys. You have to keep this thing up. Like you should be scoring 10 out of 10 in each and every session. Like you should be listening carefully. That only then you'll be able to score 10 out of 10. That's excellent. Okay. So, Shivashini, you forgot to mention the unit of that focal length. The rest of the thing are right. Right answer for the diopter, like defining one diopter power of a lens. That's absolutely right. Then Anmol, that's absolutely right for the focal length of ninth question. Right answer, Shivashin. Okay, so the 11th question is like has got repeated, right? 11th one is a repeated question, like it was there in the third question. So you can skip 11th one. Okay. And like the 12th also, it's repeated, I guess. Let me check. Yeah, was yeah, 11th and 12th is a repeated question. So as of now, we can skip those two because we already did that in the third and fourth question. Okay. All right. So I hope everything is clear to you, Zayan, Milind, Valentina, Nurul, Anushri, Shraddha, Ira, Angel, and Mol, and Shivashini. Is there any doubt in any of the question that we discussed today? No. So I'm gonna show you the answers. So for the first question, this is the answer. If you want, you can like take a screenshot or something. Like we already discussed that, like you already got the right answer. But still, if you want the step, you can go through this thing. Okay. Sometime you might get to answer right accidentally. That's why better to go through these steps. Okay. All right. So next question is here. Now the first question's diagram is here. Okay. And second question is here. And the third question is here. Yes, Valentina. Okay. So like third question is here. Like we already discussed this thing. Then the fourth question, I guess. Yeah, maybe for the fourth question. No, the fourth is here. Like this is the part of third question. Okay. Then the fourth question is here. And that was very simple. You might have, like each of you might have got the right answer for it. And I'm going to give you the next question, fifth one. And the sixth is here. And for the seventh. And for the eighth. And for the ninth one is here. And the final question, the 10th one. Okay. So that's it about our workout session. So now I'm going to activate your return test. Okay. So since you guys are not having any doubt, I have activated the return test. So like do that. Please attend that.
Ma'am, what is the seventh question? It just says
Um,
convex
yeah, let
from.
me check. You need to compare the convex and concave lens.
Oh,
Okay. So, guys, for the seventh question, you need to compare convex and concave lens. Zayan, you're writing the test, right? Your camera is off, so I'm not able to monitor you, Zayan. All right, guys, that's our time to wind up the session. But don't worry, your exam will be active there. So once you finish the session, you have to upload your answer sheet there. Okay. I hope this is clear to everyone. Is there any doubt or concern about the exam or anything? Mm-hmm. Okay. If you do not have anything, I'm going to wind up the session. So thank you, guys. Bye. Take care and all the best. So if you have any doubt, like even after the session, like you can contact the class teacher. Even after completing the chapter also, like you can contact class teacher. Okay. So we'll be there to help you all the time. So thank you. Bye. Take care. Bye bye. Good night.
Bye.